This video is going to look at how to find moles or mass in grams using the RFM, the relative formula mass of a compound. If you have forgotten how to do RFM calculations, you might want to go back over that, and there's a video for that as well. So first thing we're going to look at is just what is a mole, although you're never going to be asked what is a mole in an exam question. You're only going to be asked to find a mole, but some people just really don't like the fact that they feel like they don't know what a mole is. So if we look at these examples, we've got two atoms, hydrogen and carbon, and from the periodic table we can see the relative atomic masses, the RAMs. For hydrogen is 1 and for carbon is 12. And then a compound of carbon and hydrogen, methane here, has a formula mass, an RFM of 16, because it's made of 1 carbon and 4 hydrogens. So if we were to measure the mass of an individual particle, we could see that it would be really, really small. Okay, so one hydrogen atom only weighs 1.66 times 10 to the minus 24 grams. What that means is if you had a gram of hydrogen particles, then it would weigh this number here, 6.02 times 10 to the 20. Sorry, it wouldn't weigh, it would have this many particles, 6.02 times 10 to the minus 23. That's a lot of particles. But what that means is, if I were to take a carbon atom weighs 12 times as much as a hydrogen atom. So we take that 1.66 times 10 to the minus 24, really small number, and we times it by 12. That gives us the mass of one carbon atom. So if we take this 1 gram and times it by 12 and have 12 grams of carbon, that would contain the same number of particles as 1 gram of hydrogen. And if we did the same thing with methane, because one individual atom has a relative, for one individual molecule has a formula mass of 16, then if I took the same number of particles, this 6.02 times 10 to the 23, then that would weigh 16 grams. So all of these piles here have different masses, 1 gram, 12 gram, 16 grams, but they all contain the same number, 6.02 times 10 to the 23, of particles. And that is what we call a mole. So a pile of particles that contains the same number of particles, that's what we've got. It's given a special name, it's called 1 mole. So it's just a comparison whereby 1 gram of hydrogen particles contains the same number of particles as 12 grams of carbon, and so on. We could do that all the way through the periodic table. So all of that information is not that important. The main thing, the thing that we really, really want to get, is this bit here. So the mass of 1 mole of a substance is equivalent to the RAM from the periodic table, or the RFM if it's something like methane. So it would be RAM of 12 for carbon, but it would be RFM of 16 for methane. So this number, the number of particles, isn't actually important. If you ever needed to use it in a question, it would be given to you, and that would really be an extension question. Most of the time we want to find the amount of particles, and we just count them in moles, in the same way that we measure the amount of current in amps, or we measure distance in meters, and so on. So all we actually need is an equation that links the mass, the number of moles, the amount of moles, and the formula mass. So this is using formula mass in both of these equations. It could be relative atomic mass. What both of those is just how much a substance weighs per mole in grams. So we can rearrange this formula. This is just the same formula written in 2 different ways, because sometimes we are asked to find the mass of substance in grams, and for that we would be given the number of moles, and then we would usually find RFM from the periodic table, but we might be given it. Or we're asked to find amount of substance, and we'd be given the mass in grams, and then again we would either find RFM from the periodic table or we might be given it in the question. We can put that in a formula triangle, and so we can also have our number of moles, our mass in grams, and our mass of 1 mole. So our mass of 1 mole, that is either RFM or RAM, and we find that from the periodic table. There are a few small cases of questions where you're asked to find the mass of 1 mole and you're given the other 2 numbers, but we go over those in a separate video. So we could also shorten this triangle into a way that's easier to remember, because one thing that's a problem is that there's lots of M's. You know, you've got mass, you've got moles, you've got mass of 1 mole, or you've got RFM or RAM. So I write it like this is so that we have something easy to remember. MIG at the top, NOM down there, and this one here I would call mom, the mass of 1 mole. Okay, so what you're going to do now is go use that formula, MIG, NOM, mom, and you're going to try and rearrange it. So if we just remember how it goes, we are trying to find the mass, and we're given moles in the question. So we're going to find mass in grams, so we do number of moles times mass of 1 mole. Now for that, because you've been given formulae, you'll need a periodic table so that you can work out the RFMs, the relative formula masses, for each of these compounds in these examples. So what you should do is pause the video and then have a go at each of these questions. If you get stuck, just unpause the video, go back to it, and we'll go over them one at a time. But it's really important to try these calculations rather than just carrying on with the video. So pause the video now. Okay, so hopefully you've had a good go at these calculations. Here's the first one, nice and easy. 1 mole of water. 1 mole of water weighs 18 because there are 2 hydrogens, each weighing 1, 16 for oxygen. So I took my RFM, times it by 1. Very simple. Next one is also very simple because it's 1 mole. So really it's just asking you to work out the RFM. 1 carbon, 2 oxygens adds up to 44. If you've not got that, I would just pause it and take a look. Probably what happened was wrong number in the calculator, or you used the atomic number instead of the atomic mass. Next one, there are 2 moles this time, and the mass of 1 mole of HCl is 36.5, and so 2 moles would weigh 73 grams. For magnesium carbonate, the mass of 1 mole is 84, 0.5 times that is 42. Sodium carbonate, the RFM, the mass of 1 mole is 106, times it by 0.25, 26.5. Next one, the mass of 1 mole of sulfuric acid is 98, times it by 0.01, you get 0.98. Be really careful not to just do that in your head. Check it on a calculator. It's really easy to lose a decimal place or gain a decimal place by accident. Next one's going to be a big number. We've got 200 moles, that's quite rare. And we've got brackets here, so be careful that we understand what the brackets mean. So we've got 1 calcium, we've got 1 nitrogen in the brackets, and then we're timesing it by 2, so I've got 2 lots of nitrogen, and then my oxygen are 3 in the brackets, times by 2, so I have 6 oxygens. So that's going to give me a relative formula mass of 164, times by 200 gives me 32,800 grams. All of these are in grams because that's what's in my formula triangle, mass in grams. Okay, next thing we're going to do is find the number of moles. So my number of moles is here, and so because mass in grams is at the top, I'm going to be dividing, because that's what we mean by having the number at the top, mass in grams by mass of 1 mole. It is super common to get these the wrong way round if you don't write the formula out and think about the numbers given to you in the question. So here's some examples, not so many as the last time. Same thing, you've got RFMs to work out from the periodic table. Some of them are the same as ones you've just done in the previous question, so if you wrote them down, that'll take you a lot less time. As before, pause the video, have a go at these questions, and then carry on and check whether you're right or not. So the first one, we've got our mass in grams is 0.4. The RFM, the mass of 1 mole of sodium hydroxide, is 40, so that gives us 0.01 moles. Second one, the mass of 1 mole of water is 18. 90 divided by 18 gives me 5. This third one, 106 is the RFM. Divide 26.5 by 106, you get 0.25. Next one, the RFM of calcium carbonate is exactly 100. 1 divided by 100 is 0.01. Be careful of your decimal places again. And then the 0.2 divided by 98. Now this one is a messy number. All the rest of them were nice, easy, kind of round numbers. There weren't any long decimal places. So have a look what I've done here. I haven't just done 0.002. I've gone to 3 significant figures. So if you look after, we ignore the first 3 because they're zeros. So my 3 significant figures starts with 2, and that's a good amount if you're not told how many to do in the question. You may have also been given this one in standard form, oops, in which case I need to do it to the same number of decimal places or same number of significant figures, 2.04 times 10 to the minus 3. It's perfectly okay to do that, and all we've done there, look, is 1, 2, 3 is how many decimal places I would jump back from 2.04. That's how I've got my standard form. So it's okay to use standard form and get confident using it, because actually you would need it if you were going to do a question about Avogadro's number. At the moment though, just stick to writing whatever's on your calculator, but not a fraction, because a fraction has like an infinite number of significant figures and we can't be that accurate. 3 sig figs is the best to do.